In this video, I will explain find the Fourier transform of the following signals shown below. First one is a Gaussian signal, Gaussian signal, x of t is equal to e power minus at square. Second one is x of t is equal to e power minus at square cos omega ct. Solution. First one, x of t is equal to e power minus at square. Fourier transform of x of t is equal to minus infinity to plus infinity x of t e power minus j omega t dt. That is equal to minus infinity to plus infinity x of t is equal to e power minus at square e power minus j omega t dt. That is equal to minus infinity to plus infinity. Both are bases are equal and quotients are added. Minus at square plus j omega t dt. That is equal to minus infinity to plus infinity. Minus infinity to plus infinity. X plus y whole square is equal to x square plus y square plus 2xy. This is the formula. Here e power minus at square is equal to, this can be written as root at whole square. Root a whole square is a, t whole square is t square. That is x is equal to root a into t. 2xy. Here 2 is multiplied here and one more multiplied denominator and numerator. 2 x is root a. Here t is in that j omega t. T is there. T is present. Root a is not there. Root a by root a is multiplied here. Root a. T is present here. T is present. The remaining term is j omega. 2xy. 2xy. In the next equation, we will write in the next equation minus infinity to plus infinity e power minus root a t whole square. Here 2xy, here 2x is root a t, 2x is root a t. The remaining terms are j omega by 2 root a is the j omega by 2 root a. J omega by 2 root a is the y. This one is x. Root a t whole square is the x. 2xy. 2x is root a t. Y is j omega 2 root a. But y square term is absent. Add and subtract y square term. That is j omega by 2 root a whole square added and subtracted j omega by 2 root a whole square. Add and subtract y square minus y square. Here x plus minus infinity to plus infinity e power minus x is root a t, y is j omega by 2 root a whole square. Root a t plus j omega by 2 root a whole square. Here minus j square. J square is minus 1 minus into minus plus omega square 4 a into dt. This minus sign is applied to whole. This minus sign is applied to here also. This minus sign is applied to whole. That is minus infinity to plus infinity e power minus root a t plus j omega by 2 root a whole square minus into plus minus e power minus omega square by 4a dt. E power that is equal to e power minus omega square by 4a minus infinity to plus infinity e power minus bracket root a t plus j omega by 2 root a whole square dt. Let root a t plus j omega by 2 root a is the q. Let it be q. Differentiate derivative of this one. Root a dt. J omega by 2 root a is 0. Differentiation is 0. That is dq. dt is equal to dq by root a. dq by root a. Here e power minus omega square by 4a minus infinity to plus infinity e power minus q square. Root a t plus j omega by 2 root a is the q. That is q square e power minus q square. dt is dq by root a. dt by root a. We know that integral of minus infinity to plus infinity e power minus q square dq is root pi. Therefore, e power minus omega square by 4a by root a into root pi. This value is integral minus infinity plus infinity e power minus q square dq value is root pi. Therefore, finally answer is root pi by a e power minus omega square by 4a. This is the answer. Gaussian Fourier transform of e power minus at square. This is the first one. Second one is Fourier transform of x of t is equal to e power minus at square cos omega ct. E power minus at square cos omega ct is cos x. Euler formula is e power jx plus e power minus jx by 2. Jx is omega ct. J omega ct plus e power minus j omega ct by ct. By this one is 1 by 2 e power j omega ct into e power minus 80 square plus 1 by 2 e power minus j omega ct into e power minus 80 square. Fourier transform of this one is also Fourier transform of this one. Therefore, 1 by 2 Fourier transform of e power j omega ct into e power minus 80 square plus 1 by 2 Fourier transform of e power minus j omega ct e power minus 80 square. According to e power j omega naught t frequency shifting x of omega minus omega naught. Here omega naught is omega ct. Here omega naught is minus omega ct. And also Fourier transform of e power minus j omega naught t x of t is x of omega plus omega naught. By using and Fourier transform of e power minus 80 square is root pi by a e power minus omega square by 4a. Apply this function frequency shifting Fourier transform property here. Here omega x of this one is x of omega. This one is x of t. This one is x of t. But omega is shifted by a function omega c. Here Fourier transform of e power j omega t x of t is x of omega minus omega naught. Same principle is applied here. 1 by 2. X of t is here x of omega. Here omega is also there. Root pi by a e power minus here omega ct. Fourier transform of e power j omega naught t x of t is x of omega minus omega naught. Here omega naught is omega c. Therefore, here omega is replaced by omega minus omega c whole square by 4a plus 1 by 2 square root of whole square root of root pi by a e power minus here omega is replaced with Fourier transform of e power minus j omega naught x of t is x of omega plus omega naught. Here minus sign is there. Here omega is replaced with omega plus omega c whole square by 4a. Finally, the answer is for the second question 1 by 2 root pi by a is the common term e power minus omega c whole square by 4a plus e power minus omega plus omega c whole square by 4a. With this, the analysis is completed. If you like this video, subscribe the channel for further updates. Thank you.